Chapter 3 is an introduction to organic molecules and functional groups. And in this chapter, we'll look at what functional groups are, we'll look at intermolecular forces and at physical properties of organic molecules. And we'll look at a couple interesting applications of organic chemistry to biology. So the first thing that we want to ask is, what is a functional group? What am I even talking about? And a functional group is an atom or a group of atoms with characteristic chemical and physical properties. So typically functional groups imply things that are other than CC and CH single bonds. These are the common backbone of all organic molecules. So where are things different than that? And oftentimes too, it relates to where are organic molecules reactive? And the common places where organic molecules are reactive are at heteroatoms, so those are things other than carbon and hydrogen, things like nitrogen, oxygen, sulfur, phosphorus, halogens. X is the generic for halogens again. And why? Why would organic molecules be reactive there? Well, for a couple reasons. For one, they make polar bonds to carbon. Or hydrogen that are more easily broken. And along with that, they create electron deficient sites on carbon. And as well, most of them have lone pairs that can react. And the second one is pi bonds. And pi bonds make organic molecules reactive because they're easily broken. Again, remember that pi bonds are weaker than sigma bonds. And because they're easily broken, they can make a molecule a base or a nucleophile. In this next section, we'll look at all of the functional groups that we'll use this year for organic chemistry. Starting with the simplest one, and these are hydrocarbons. Hydrocarbons means that it's only C and H. Yet there are still functional groups in that. So we have aliphatic hydrocarbons, and in aliphatic hydrocarbons we can have alkanes that have no multiple bonds. We can have alkenes with a double bond. And we have alkynes that have a triple bond. If you want to look at where these are in the book, we'll talk about alkanes in chapter 4, we'll talk about alkenes in chapter 10, we'll talk about alkynes in chapter 11. So an alkane might be something like this. This could be an alkene. And an alkyne. Alkanes, all single bonds. Alkenes have a double bond. Alkynes have a triple bond. And the second category of hydrocarbons are aromatic hydrocarbons. And we won't really talk about those until next semester. But aromatic hydrocarbons are compounds related to benzene. We'll talk about those next semester in chapter 17. The next group, after hydrocarbons, are compounds that have a CZ sigma bond. And here Z is just a generic for any electronegative atom. Meaning atoms that are more electronegative than carbon. So some common possible ones here are alkyl halides, which have some kind of a chlorine, bromine, iodine, fluorine on them. Alcohols, that have a carbon with an OH on it. Ethers, which has an oxygen that has carbons on both sides. And amines. Amines have sort of flexible structure. They can have an NH2, you can have an NH, or they can be nitrogen with carbons on all sides and have no NHs on them. So again, looking back to where we'll talk about these, alkyl halides are in chapters 7 and 8, alcohols, chapter 9, ethers, chapter 9, and amines are not until the very end of the year of Organic 2, chapter 25. The next broad category are compounds that have a carbonyl, CO double bond in them somewhere. It seems like that would be very limiting, but let's look at the examples that there are. So if we have a carbonyl with a hydrogen on one side, we'll call that an aldehyde, and carbon on the other side. If we have a carbonyl with carbons on both sides, that's a ketone. If we have a carbonyl with an OH on one side, that's a carboxylic acid. If we have a carbonyl with an O with other alkyl groups on it after that, that's an ester. If we have a carbonyl with amine groups on it after that, that's called an amide. If we have a carbonyl with an X, so a halogen, that's an acid halide. And among that, we have specific categories. We could have an acid fluoride, an acid chloride, acid bromide, an acid iodide. And if we have a carbonyl followed by an oxygen and another carbonyl, that's an acid anhydride. So when I look at these in the chapters, carboxylic acids are in chapter 19, and all the rest of the carbonyl compounds are in chapters 20 through 24. So while it seems rather limiting to talk about molecules that have one specific group, a carbon-oxygen double bond, you can see there are 6 chapters in a row in second semester in Organic 2 where we'll talk about molecules that have carbonyls. They're very common in organic chemistry.